Hello and welcome back to the course on machine learning. And in this section, we're talking about the k-means clustering algorithm. And in this tutorial, we're going to talk about the intuition behind k-means. So k-means is a algorithm that allows you to cluster your data, and as we'll see, it's a very convenient tool for discovering categories or groups in your dataset that you wouldn't have otherwise thought of yourself. And in this section, or in this specific tutorial, we'll learn how to understand k-means on an intuitive level, and we'll see an example of how it works. So let's dive straight into it. Let's make this topic, this complex topic, simple. All right, so here we've got a scatter plot. And how does this scatter plot come to be? Well, let's imagine that we've got two variables in our data set, and we decided to plot those two variables on the x and y axis. So here we go, that's one variable, that's the other one, and this is how our observations are configured according to these two variables. So the question here is, can we identify certain groups among our variables, and how would we go about doing it? Can we maybe identify this is one group and this is a second group, or maybe this is one group, the second, or maybe there's four groups or five groups, maybe there's three groups. How do we identify the number of groups? How do we identify the groups themselves? So what the k-means does for you is it takes out the complexity from this decision-making process and allows you to very easily identify those clusters. They're actually called clusters of data points in your data set. So there we go. In this case, we have three clusters. And of course, this is a very simplified example. We only have two dimensions here, so two variables. K-means can work with a multi-dimensional object, so it can work with 3, 4, 5, 10 dimensions. This example is just for illustrational purposes so that we can visually see what's going on, but in reality they can be as many as 10, 100, any number of variables, and k-means will do that complex calculation for you. So it's an algorithm designed to find these clusters for you. And today we're going to find out a bit more on how the k-means algorithm works. So what is the step-by-step process? This is my favorite part. We're going to break it down to such a simple step-by-step process that it'll be extremely intuitive and simple to understand. All right, so step one for the k-means algorithm is to choose the number of clusters k. And we'll talk more about how to select the optimal number of clusters further down in this section of the course. But for now, let's imagine that we've agreed on a number of clusters for a certain challenge. And let's say we've agreed that there's 3 clusters, or there's 5 clusters, or 2 clusters. And once you've done that, then you proceed to step 2, which is to select at random k points, which will be the centroids of your clusters. And not necessarily these points have to be from your dataset. So as you saw, we had a scatter plot. You could select any points on that scatter plot. They don't have to be part of the observations that are plotted on the scatter plot. They can be any random x and y values on your scatter plot, as long as you just select a certain number of centroids that are going to equate to the number of clusters that you have decided upon. Again, we'll see this in practice just now. Then you move on to step 3, where you assign each data point to the closest centroid. And that will form k clusters right away, immediately. So that's your starting clusters, and then there's going to be an iterative process to refine those clusters. And we'll see this in action, but basically, so you just check for every point in your dataset, which out of the centroids that you've identified in step 2, which of them is the closest to your specific data point. And then that's where that data point will be assigned to. And closest is a kind of a vague term here, because what kind of distance are you measuring it by? Is it Euclidean distance? Is it some other sort of distance? That can be better defined in your business challenge, but for the purposes of these tutorials, we're going to talk about Euclidean distances. And so that's basically geometrical distances in simple terms. All right, step 4, where you proceed to after step 3, is to compute and place the new centroid of each cluster. And we'll see how that's done just now. So once you've found your clusters, you recalculate the centroids. Again, it's going to be much easier to understand this when we look at an example. Then in step 5, you reassign each data point to the new closest centroid. So basically you perform step 3 again, but we'll just call it step 5 here. And then if any reassignment took place, you repeat step 4. So it becomes an iterative process of step 4, step 5. And if no reassignment took place, you go to finish and your model is ready. I know this might seem a bit complex, but let's go through a visual example now so that we understand this on a very intuitive level. And then you can always reference this slide or this step-by-step rule further down when you're actually performing k-means clustering, or when you want to understand how it's happening and what's happening in the background of k-means clustering. So this slide will be a great reference point after we discuss this visual exercise that we're going to have just now. So let's move on. All right, so there is our scatter plot, and here we've got the observations in our dataset. They're plotted against 2 variables. And right away, the first question is, can you visually just quickly identify the final clusters that you think that we'll end up with? It's pretty tough, isn't it? And that is even when we just have 2 variables. Imagine how complex this situation or this challenge would be if we had 3 variables or 5 variables. We wouldn't even be able to plot a 5-dimensional scatter plot like that. So that's where k-means clustering comes into play, and that's where this algorithm will help us simplify the process. So let's see how it will perform in action. So in this case, we're actually going to manually perform the k-means clustering algorithm. So something that would normally be done by tools of your choice, for such as R or Python or any other tool. But in this case, just so that we can get very comfortable with this algorithm, we're going to do it manually and see exactly how it works. All right, so let's go through the steps. Step 1, choose the number of clusters k. And let's say we somehow identified that the optimal number of clusters is equal to 2. Again, we'll discuss how to find the optimal number of clusters further down in the section, but for now, let's agree that for this challenge, it's just 2 clusters. All right, and then step 2, select at random k points, which will be the centroids of your clusters, and not necessarily from your dataset. So what that means is that they can be actual points in your dataset, or they can just be random points on your scatter plot. It doesn't matter where you select them. So let's say we selected these 2 centroids, the blue centroid and the red centroid. Next step is step 3, assign each data point to the closest centroid, and that will form k clusters. So basically, for every data point in our data set, what we need to do is identify which of the 2 centroids, blue or red, is the closest. So let's say for this data point, obviously blue is closer than red, so it would be assigned to the blue cluster. For this data point, blue is again closer than red. For this data point, red is closer than blue. And so we could keep going like that for every data point and assign it to one of the 2 centroids. But we're going to use a quick hack here. We're going to use something that we learned from geometry. So what we're going to do is we're going to just connect these 2 centroids with a line like that. And then we'll find the center of the line, which is over here, and we'll put a perpendicular line exactly through that center like that. And so from geometry, we know from high school geometry, or maybe at university, or even if you didn't have geometry, it's a very straightforward concept that any point on this green line is equidistant from the blue and the red. So if I take this point, it will be the same distance to the blue centroid and to the red centroid. If I take this point, it'll be same distance to blue and the red. So this whole line is equidistant to the blue and the red, and that's how we constructed it. And so based on that, it now is obvious that any of our points on the scatter plot above the green line is closer to the blue, and any of the points below the green line is closer to the red. And that's how we're going to just color our points. It's a very quick way of coloring them. Again, you could totally go through every point and individually identify which one to which centroid is closest, but just for our sake, while we're doing this exercise, it's going to be faster if we apply this quick hack method. So there we go, we've colored our centroids, or our points on our scatter plot. Before we continue, I do want to mention something here, that closest is a very even though it seems straightforward, it's quite an ambiguous term because closest, when you're visualizing things on a scatter plot, yes, it's pretty straightforward that it's the distance, right? But at the same time, in mathematics and in data science, there's lots of different type of distances. Like the one we're using is Euclidean, and the question is, should you be using Euclidean distances or should you be using some other type of distances defined for your challenge? And that is something up to you to decide, and something for you to specify for the algorithm what type of distance you're going to be using. But for our sake, we're just going to be using Euclidean distances for the illustration purposes. And basically, that's just a very straightforward, simple geometrical distances between two different points. So that's just a caveat there. And if you'd like to research more about distances and what other kind of distances you can use, just make sure to look into that, because for some challenges, sometimes you might want to use non-Euclidean distances that are defined in other specific ways. All right, so with that in mind, let's proceed to step 4. Step 4, compute and place the new centroid of each cluster. So basically, right now we've got the new points, all the blue ones excluding the centroid itself, and all the red ones excluding the centroid itself. And we need to find out where the actual centroid, the new centroid for the blue points is, and the new centroid for the red points is. And the way to think about it is, imagine that the centroids themselves, they are weightless, but these other points, they have a certain weight, say, let's say 1 kilo each. Then you need to find the center of mass or the center of gravity of these centroids, and you need to pinpoint it on your scatter plot. So for the blue cluster, it'll be somewhere here. For the red cluster, it'll be somewhere over here. And the way to think about it on a two-dimensional scatter plot, you kind of like can just visually see where it is, or you can just look at the x, let's say the y coordinates for all of the blue points, and find the center of gravity for the y coordinates, which will be somewhere here, and then do the same thing for the x coordinates, find the center of gravity, which, or like the average of the x coordinates, which will be over here. So that's how you get your new centroid for the red and blue clusters. And so we just move our centroids into them. Next, you perform step 5. So reassign each data point to the new closest centroid. And if any reassignment took place, then go back to step 4. Otherwise, you may finish your algorithm, meaning that it has converged. So let's do that. Let's see how now the data points will reassign to the new centroid. So if we put our line through the scatter plot, you'll see that there is 1 point, or no, there's actually 3 points. This point is closer to the blue than to the red, and these 2 points are actually closer to the red than to the blue. So now we will recolor them. There we go. So now we've got a new clustering, and some reassignment did take place. So we're going to proceed back to step 4. So we're going back to step 4, compute and place the new centroids for each cluster. Same thing, find the center of mass for this centroid, find the center of mass for this centroid, place the centroids in those locations, and now repeat step 5, reassign each data point to the new closest centroid. So we're going to put the line through the chart, so the equidistant line between the two centroids. As you can see, this point is actually now in the blue cluster rather than being in the red. Reassign that point. And what happens next is, again, we return to step 4. So if I go back here, you'll see that a reassignment did take place. So we're going back to step 4. And that's where our new clusters are going to be located, our new centroids. Move them there. Repeat step 5. As you can see, it's an iterative process, which is going to keep going like this until the algorithm converges. So there's our equidistant line. As you can see, 1 point needs to be reassigned. It gets reassigned. So now we go back to step 4, compute and place the new centroids for each cluster, move our centroids, and now reassign each data point. So repeat step 5. And as you can see, this time, the equidistant line does not make any points reassigned. So as you can see, all of the points are already in their correct clusters. And that means no reassignment took place during this step, so we can proceed to completing our algorithm. This means that the algorithm has converged. So there we go. Those are our clusters and the model is ready. And so now we can just remove the centroids and the equidistant line, and there we go, that's our final result. So as you can see, that's how the k-means algorithm works. It's very, very intuitive and straightforward, just an iterative process. And if we compare it to what we had at the start, this is what we had. As you can see, it's not that obvious how the clusters would have been arranged. For instance, you might have thought that maybe this could be a cluster on its own, and this could be a cluster, or maybe this bottom part would be a cluster and this top part would be a cluster. But based on the k-means algorithm, what we got as a result is these two clusters. So the points in each cluster are not exactly very similar to each other, but this is what the k-means algorithm is suggesting. Hopefully you enjoyed this tutorial, and hopefully now we've demystified the k-means algorithm and we've broken it down into simple terms. And I look forward to seeing you in the next tutorial. Until then,